I can't break down a base of 3, but what could you do to 9?
Break it down.
You have to resist the temptation. A lot of times I see people that just want to add a square in here and make that 3 and 9. But you have to do what's equivalent. If you square one side of the equation, you would have to square the other. So if you're going to do that, you have to change both sides. So you could still get the answer that way as long as you did it correctly, but it's easier just to rewrite this with what it's equivalent to. So 9 is the same as 3 to the second power. And with those exponents, if you have a power to a power, what do? So 3 to the x cubed equals 3 to the 2x. So at this point, we have a base of 3 on each side. So now we would set the exponents equal to one another. So x cubed equals 2x. How do I solve that? Well, if it was like x cubed equals 2, yes, but we have an x on both sides. Okay. Yes and no. So that will help us, but we lose the solution by doing that. So thinking along the same lines, what we're going to do is put the x's on the same side. And then instead of dividing by that x, we're going to factor it out. So now you have two things multiplied that equal 0, so you can set each thing to 0. So x equals 0, or x squared minus 2 equals 0. Okay, so there's one answer. To get this one, you add your 2, square root, plus and minus. So we get 3 possible answers here. X could be 0, or positive or negative square root of 2. So you may get multiple answers on these. And again, you should be able to check them. You could always plug them back into the original and they should all work out. Let's look at this problem. Can I just multiply that 4 and 2 to get 8? No. Order of operations says you have to do exponents before you multiply. So I cannot combine the 4 times 2 because they have exponents. Okay. So change that 4 to a 2 squared. I still have 2 to the x squared power. What about the 16? Alright, so this becomes 2 to the 2x times 2 to the x squared equals 2 to the 8. Now I can't drop my base yet because I have to have just 1 on each side. So on the left, when I have 2 to the 2x times 2 to the x squared, what do I need to do with those exponents? So now we have the base once on each side, so we can drop the base, set the exponents equal. Subtract the 8. Alright, so what multiplies to negative 8 and adds to positive 2? Set each of those to 0, so x is a negative 4 or a positive 2. And again, we can always check. I'd like to do just a couple more examples along this line. Does that E change anything? E is just a number. So it's the same idea. What would I do with that 1 over E squared? Yeah, if you just wanted to flip it and bring it up to the top, the exponent would be negative. I think we had one yesterday that was like a 1/5 and a 1/25, and we talked about flipping it with the negative exponent. So this means e to the x squared equals e to the 3x times e to the negative 2. So then on the right, if I'm multiplying these e's, what happens to the exponents? So then we can drop the e. So quadratic, so we have to set it equal to 0, so subtract 3x, add the 2. So if we set those equal to 0, we get positive 2 and positive 1. Any issues with these guys? Last one. Okay. So what would be my common base here? 5. Okay. So a cube root, you would write that as 5 to what power?
To the 1/3.
Okay, 1/5, that would be 5 to the So now the exponent rules. Power to a power we multiply. I don't know what's going on here. So I get 5 to the negative 1/3 x equals 5. If I distribute my negative, negative x minus 2. So now you can set your exponents equal. If we add over our x, negative 1/3 plus 1 would be a 2/3. Either divide by 2/3 or multiply by the reciprocal 3/2. And we get x to be negative 3. So you can do the same thing with radicals. If it's a square root, what would your power be? 1/2. Cube root, 1/3. You just put the index on the radical goes in the denominator. Okay, there are I think a couple questions on the homework that are a little bit different. If you're looking at like 17, 18, 19, those are different. The variable is the base, not the exponent. So I wanted to try a couple like that. And I don't know why this printed so weird, but this is b to the 5/2 power equals 243. Okay, there are different ways of solving this. If we think about a 5/2 power, what does that mean? It's
square root and as a power 5.
And the 5th power could be under the radical or outside the radical. Either way, it's fine. The same. Okay. If I want to get rid of b, we have to get rid of the square root and we have to get rid of the 5th power. Doesn't matter which one we get rid of first. So what do you want to do? Square root. So the opposite of a square root is a square. So So the square root and the square drop, so I have b to the 5th equals 243 squared. All right. How do I get rid of a 5th power? Do I need a plus or minus?
No.
No. When do you have to have a plus or minus?
Even.
It's an even root, a square root, 4th root, 6th root. Okay, and then the 5th root of 59,049. 9. And we can easily check that. If you plug it back in, 9 to the 5/2 power, just type in your calculator, you get 243. All right, so B, this says h to the 4/3 power equals 81. So in radical form, that means the cube root of h to the 4th equals 81. How do you get rid of a cube root? Cube each side. So 81 to the 3rd is 531,441. Then to get rid of a 4th power, 4th root, which would also get
27.
So again, we have to have that plus and minus because it was an even root. Plus and minus 27. Is this stuff okay? Alright, so that's part 1 of class. Part 2, you have some time to work on the homework. I'm going to stop you towards the end of class and do a little bit of an introduction for tomorrow's lesson.
And this is due.
And so we are going to do some interest tomorrow. I just wanted to discuss the formulas today so that we can jump right in and work examples tomorrow. So just some common terms. When we're talking about interest, if I say we pay annually, what does that mean? Okay. Semi-annually.
2 times a year.
Quarterly.
4 times.
Monthly.
Something.
You're excited.
Okay, and this is the one that I always have a lot of people that struggle with. What does daily mean? Good. You guys know how many days are in a year?
Unless it's like.
We will assume it's not a leap year for our calculations.
And it could be 365 and 1/4.
We're not that precise.
Maybe a million every leap year. Here's 4 years.
So in talking about interest, we are not just looking at simple interest. We did simple interest at the beginning of the year, principal times rate times time equals interest. We are going to be talking about compound interest. So these formulas will be given to you. I will have them on any test or quiz. I'm just not going to tell you what the variables stand for, so you have to know that part. So in this, A is like your ending amount. Sometimes that's referred to as the future value, what you will have in the future. P is your principal. Sometimes that's called your present value. It's what you have right now. R is your interest rate as a decimal. Come on in. T has to be time, but it has to be measured in years. Your R, your interest rate, is always a decimal. And N is the number of times we compound each year. So that's from that previous slide where we wrote down all those different N values. So that's the first formula we will be using when I refer to compound interest. And the last formula, the last thing I want to mention today, if I say it's compounded continuously, the formula is A equals PE to the RT. So A is still your ending amount, P is still your beginning amount, R is still your decimal rate, and T is still your time in years. So I just wanted to touch on that. We will actually